In this particular part of the video, I like to focus on the topic of solution. Solution is made up of both solute and the solvent. Now, solution is further divided into strong, weak electrolyte, and non-electrolyte. But let's go ahead and define what an electrolyte is and a non-electrolyte is. So here I have an image of sodium chloride being submerged into water. When it's submerged into water, this dissociates. Sodium chloride is an ionic compound. Not only is it an ionic compound, it is soluble in water. Not only is it soluble, they're able to dissociate in water, meaning that they're able to split into these positive and negative charge individual ions. When this occurs, if the right amount of the right wires and battery is provided, this can allow a light bulb to light up. So you can see on the very left-hand side over here, positive and negative charged sodium and chloride. And you see there's a light bulb that can light up because there is a flow of electrons allowing it to pass through when there is a positive and negative charge ions. So we can define electrolyte here. Electrolyte is a substance like the sodium chloride that can dissolve or dissociate into positive and negative charge in water. Now, and it'll produce a solution that can conduct electricity, hence the name electrolyte. So if you're wondering if your Gatorade or Powerade electrolyte drinks are able to do this, as long as there's a positive and negative charge ions, they can. Then what is a non-electrolyte? A non-electrolyte can dissolve in the water, meaning that once you put it in, you can't see the solid substance. However, because they cannot dissociate into positive and negative charge in water, they can't produce a solution that can conduct electricity. This is an example. Here's an ethanol that is going into the water. They don't dissociate, meaning it doesn't split apart into positive and negative charge counterparts, but rather it does dissolve. Something like this would be like a molecular compound. It's able to dissolve, meaning that it is soluble, just like the sodium chloride. However, because they do not dissociate, they don't split apart, and they don't have a charge. It's just the whole thing dissolves in itself. Now you can see in this image, there are three different types of electrolyte. The one on the very left is the strong, the middle is the weak, and the very right-hand side is the non-electrolyte. If I were to compare all of these three, let's say I look into the strong electrolytes first. The strong electrolytes will have 100% of the ionic compound that is being dissociated. So here you see ion, 100% of them. Once they work together, now all of them are split apart. Then in a weak electrolyte, some still stays intact, only few are split apart, so only few dissociate. So I wrote under 100% dissociated ions. Then we have non-electrolyte, none will dissociate and it can't conduct any electricity current, and so you don't see any light bulb change.